Hello everyone, my name is Jocelyn Callahan and today we're going to talk about AI, its consumption of water, and why it matters. Artificial intelligence, or AI, has become part of everyday life for millions of people around the world. Every day, people use tools such as ChatGPT, Microsoft Copilot, Google Gemini, Meta, Claude, Grok, and so many more. It seems like every tech company out there has an AI tool or assistant of some kind. There are dozens of AI resources that people use every single day without stopping to think about where those tools get their knowledge. What happens behind the scenes to make that silly picture, find the best recipe, or whatever else you can think to ask it for. When we ask AI a question or submit a prompt, the AI tool relies on a data center to give it a response. Data centers are enormous buildings and campuses that require massive amounts of power. The data center stores the information and computing power for the model to find the answer to your query. Recently, there have been many conversations about AI that often focus on real but intangible risks and drawbacks. But another important issue that receives less attention is the environmental impact. Today, I'll explain how AI and data centers use water, why that matters, the environmental consequences we're seeing, and what companies and governments can do, and are doing in some cases, to reduce these impacts. What is AI? So, artificial intelligence refers to computer systems that perform tasks that normally require human intelligence, such as answering questions, recognizing images, translating languages, or generating text. They use large banks of information to search the entire internet to give a response almost instantly. Every AI model runs on thousands, or even hundreds of thousands of specialized computer chips located in huge buildings or groups of buildings called data centers. Data centers are large facilities filled with servers that store these information and process the digital requests, just like the one you see here in this picture. Each building is massive and filled with computers and chips. Companies like Microsoft, Google, Amazon, and OpenAI operate data centers like this one around the world to power cloud computing and AI services. Just like we've probably all experienced, if you run a computer for too long, it gets hot. It just happens. It happens with laptops, phones, and really any kind of electronic device. Inside these data centers, with the thousands of computers running 24/7 all at once, there's a large amount of heat created. Because of this, cooling is one of the biggest challenges for every data center. If the equipment overheats, it becomes less efficient, producing even more heat, and can fail entirely. In order to keep these systems running smoothly, the companies that own data centers use water. Water absorbs heat extremely well, making it an efficient and simple way to keep servers operating safely. Water has a few different sources, including blue sources, which mean they come from groundwater, gray sources, coming from reclaimed water, and piped straight from municipalities. Most of the water used by data centers and cooling processes come from municipal water plants, like the image on the left. Most of the water used by data centers is used directly in cooling systems, like the example shown in the middle image. That image shows server racks filled with cooling systems with cold water pumping through it constantly. Some facilities use water through cooling equipment, while others use evaporative cooling towers. As Dr. Alex Tabibi explains in his Green.org article, in evaporative cooling, the system turns clean water into vapor, which then carries heat away from the system, which relies heavily on municipal water supplies. These are the same supplies used by homes and businesses, which only increases the demand for this finite resource. In Cooper Ellsworth's study of Google's data centers, it was found that about 80% of water taken in by the facility was completely consumed, meaning it was evaporated and not able to be treated or reused. Once water has finished absorbing the heat and cooling the system, several things can happen. Some of it is recycled through the cooling systems, but a significant amount evaporates during this process. Through the water cycle of evaporation, condensation, and precipitation, the water will eventually return back to Earth. But that process takes a long time and does not address the imminent loss of available water. Some companies are beginning to use recycled and reclaimed water, but overall, fresh water from municipalities remains the most common source of water used by data systems. This is especially concerning in areas experiencing drought or areas that are already water insecure, where every gallon of water matters. Water is not the only resource that AI consumes in large quantities. It takes a lot of electricity to run thousands upon thousands of computer chips in each data center, not to mention the initial electrical needs to train the AI models while they are learning and gathering information. As Dr. Tabibi explains, training a large language model like ChatGPT involves running countless GPUs for weeks or even months, continually processing massive data sets. This learning period done by the AI models can account for half of all of the resources it will consume in its lifetime. The chart you see here was created by Cooper Ellsworth and his team and shows the energy used per AI prompt in a few large production AI models. On the chart, the larger values show where more prompts can be generated with the same amount of kilowatt hours. The red dots and bars represent Meta, green is ChatGPT, and blue is Google Gemini. The gray text represents estimated metrics where the researchers didn't have actual numbers, and the black text is measured actual data. As AI adoption continues to grow, electrical demand from data centers is also increasing rapidly. In Ohio, utility companies are expanding power generation specifically to meet this demand, but some are passing that cost on to local residents to encourage the construction of new data centers. Also, it is worth noting that many energy companies in Ohio use fossil fuels to provide electrical energy. The relationship between fossil fuels, greenhouse gases, and climate change is widely known. The more fossil fuels burned, the worse off the effect on the planet. And so, the more electricity is needed and used by data centers, the more energy is used, the more fossil fuels are burned, and the more greenhouse gases are put into the atmosphere. More than just the environmental factors, the increasing use of AI raises several other concerns to the public. There are ethical issues involving misinformation, so-called AI hallucinations or manufactured information, deepfakes, copyright infringement, privacy concerns, and biases in AI systems. Also, potential fears of cognitive decline and loss of critical thinking skills over time, especially in children and younger people. There are also economic concerns, including job replacement in some industries and increasing concentration of power among a small number of companies within the tech industry, which some people fear may lead to a monopoly. As AI becomes integrated into more products and services, these impacts will likely continue to grow exponentially until better solutions are found. As I mentioned previously, AI has a huge impact on the environment and can have a large carbon footprint. Building AI in computer hardware requires mining rare earth minerals and manufacturing specialized computer chips, both of which consume large amounts of energy. Construction of new data centers also requires concrete, steel, and other carbon-intensive materials. Operating data centers produces carbon emissions wherever electricity comes from, coal, oil, or natural gas. Although many technology companies have committed to renewable energy and carbon reduction goals, AI's rapid expansion is making those goals more difficult to achieve because the demand is growing so quickly. according to a peer-reviewed paper written by Rushin Patel, Nikhil Mahalingam, and Adi Patel at Rutgers University. When thinking about how much electricity is used at data centers, AI servers in the United States could generate an additional 24 to 44 million metric tons of carbon dioxide equivalent emissions annually by 2030, less than 4 years away. In July 2025, Elio Masciari and Enia Vincenzo Napolitano from the University of Naples Federico II proposed an equation to compute the environmental impact of AI models as the quantity of carbon dioxide equivalent that is generated by an AI task. They focused on putting environmental impact into numbers specifically to contribute to the development of more sustainable and innovative AI that take care of the environment rather than contributing to ecological degradation. In the chart shown here, the pair of researchers looked at several large language models, or LLMs, and include data about the number of parameters looked at, the hardware used by each model, and the number of hours each model spent learning or training. They then calculated the energy used in that process, and from that calculated the carbon dioxide equivalent emissions that resulted from the LLM's learning processes. Water consumption. Fresh water is a limited resource. Water makes up most of the earth, but most of that water is salty or ocean water, which cannot be consumed on its own. According to the Environmental and Energy Study Institute, only 3% of water on Earth is fresh water. And of all water on Earth, only 0.5% is accessible to humans. Many communities around the world already face drought, declining groundwater supplies, and increased competition for limited water resources. Houses, farms, businesses, manufacturing facilities, and more are all vying for the same finite resource. Shown here is a map of Ohio showing where all data centers are and how many. If you're familiar with the geography of Ohio, you'll see that these data centers are centralized around the largest cities, where there is the most need for water. When a data center is built, it consumes huge amounts of water every day. The EESI claims that large data centers consume up to 5 million gallons per day, equivalent to the water use of a town populated by 10,000 to 50,000 people. That comes out to about 1.8 billion gallons annually. While a medium-sized data center uses about 110 million gallons of water per year, equivalent to the annual water usage of approximately 1,000 households. According to the EESI, as of March 2025, there were 5,426 data centers across the U.S. that consumed 449 million gallons of water every day and 163.7 billion gallons annually. Climate change makes this problem even more serious by increasing temperatures and making droughts more frequent in many parts of the world. AI can also increase the impacts of climate change, which only worsens the problem, like a negative feedback loop. As AI usage continues to expand globally, understanding and managing its water consumption becomes increasingly important. After hearing about all these negative aspects of AI and the harm it is doing, you might be asking yourself, why do we still have AI if there is so much wrong with it? What possible benefit could come from all of these negatives? AI can act as a virtual assistant and help everyday people with menial tasks. In the medical field, AI can help doctors analyze medical images and support scientific research. Also, AI can help translate languages and assist with communication. Many new models often focus on increased language translations. AIs can also help businesses become more efficient, both within their business models and become more environmentally conscious. As Zohar Ahmed writes in his Technological Forecasting and Social Change journal piece, AI is a powerful catalyst for sustainable growth, offering solutions to complex environmental challenges. Its potential is vast, ranging from optimizing energy use in smart grids and improving efficiency in supply chains to enhancing waste management and facilitating climate modeling. Data centers also power more than just AI. They support online banking, email, video streaming, cloud storage, education, and emergency communications, and countless other digital services people rely on every day. In his article titled Sustainable AI, Filippo describes three frameworks of AIs that work together to have a positive impact. Green AI focuses on aiming to minimize energy consumption and carbon footprint during development and deployment. Ethical AI describes the moral principles and guiding AI development and use. And sustainable AI is the balance between humanity, the environment, and technology. Fortunately, there are some companies and researchers working on solutions around the AI issues. Some companies are designing more efficient computer chips that produce less heat. Some data centers are switching from freshwater to reclaimed or recycled wastewater, and others are experimenting with liquid cooling systems that use significantly less water than traditional cooling methods. Technology companies like Microsoft, Google, and Amazon have also announced goals to become water positive, meaning they aim to replenish more water than they consume through conservation and restoration projects. In 2023, Google adopted their water risk framework that makes certain all new data centers developed in high-stress locations will make use of air-cooled technology during normal operations. Some AI researchers are also developing models that require less computing power, making them more efficient and saving water and electricity in those ways. Overall, there is not one single solution to this complex problem, but rather a collection of solutions that will all do their part in solving the big picture. First, companies should build data centers in locations where water is more abundant and where renewable energy is available. In my research, I even read about one company that specifically builds data centers on the ocean floor and uses the naturally low temperature of the water to cool their equipment. Second, data centers should prioritize using recycled or reclaimed water instead of potable fresh water whenever possible. This is a solution currently being used by some companies already. It keeps the fresh water in its current liquid form and able for future consumption. Third, governments should require greater transparency so companies will publicly report their water and energy consumption. Transparency fosters competition, which will force companies into researching better and more effective methods. Government transparency also prevents corruption and collusion among the top companies. Zohar Ahmed concludes, corruption typically worsens environmental outcomes by weakening regulations, hindering innovation, and creating inefficient energy systems. The only way to prevent corruption is with transparency. As Dr. Tabibi says, meaningful progress requires both data and context, along with the willingness to confront trade-offs honestly. Fourth and finally, consumers have a role to play by using AI thoughtfully and supporting companies that prioritize environmental sustainability. Consumer choice plays the biggest role in what companies succeed or fail. And if consumers choose to only support AI companies with responsible practices, that will force other companies to follow suit. responsible innovation means balancing technological progress with responsible resource management. When discussing AI and its overconsumption, it is easy to see the negatives and form a negative opinion. However, there is some good in technological innovation. The proper goal shouldn't be to eliminate AI, but to develop and use it responsibly. Artificial intelligence is transforming our world and offers enormous potential to improve healthcare, education, science, and many other fields. However, these benefits come with environmental costs that often remain invisible to users. AI depends on data centers, and data centers require significant amounts of electricity and water. Some companies are already making progress through improved cooling systems, recycled water, renewable energy, and more efficient AI models. But there is still a lot of damage being done to the environment as AI expands and continues to grow. The efforts for sustainable practices need to expand even more as AI continues to grow. We all, governments, technology companies, researchers, and consumers, all have a role in ensuring AI develops in a way that is both innovative and environmentally sustainable, and we owe it to future generations to grow AI in a responsible and sustainable way. Thank you all for listening to my discussion of AI and overconsumption. If you would like more information about any of the information I share, listed here are the resources that I used in my research. Thank you and have a wonderful rest of your day.